Welcome to Study Loop.
Hello students, in this question a platform is executing simple harmonic motion in vertical direction with an amplitude A equals to 5 cm and frequency F equals to 10 divided by pi vibration per second. A block is placed on the platform at the lowest point, so we have to determine for the part A at what point the block will leave the platform. So x we have to determine. So we know that the equation for the acceleration x double dot, it is equals to minus a omega square sine omega t. So this is the acceleration. So the mass will leave the platform when this x double dot will be equals to the gravitational acceleration g in the downward direction. So minus g, it is equals to minus a omega square sine omega t separation. Okay, so this is the time for the separation. So from here the separation time, it is equals to 1 by omega arc sine of g divided by a omega square. So we can calculate the position. So x will be equals to minus a sine omega t. So this is the position x. Okay, so substituting this time will be ts. So substituting the value of the ts here, so we will get a sine omega and ts is equals to 1 by omega arc sine of g by a omega square. So this value will be reduced to x equals to g by omega square. So g is 9.8 meter per second square divided by omega. From here this can be calculated. So omega is equals to 2 pi f. So 2 pi multiplied by frequency is 10 by pi. So we get from here 20 radian per second. Okay, radian per second square. It is angular frequency, so radian per second will be there. So 20 and this whole square. So from here x, this is nearly equals to 0.02545 meter. So this become the answer for the part A. Now solving for the part B, we have to determine how far will the block rise, that is height h, above the highest point reached by the platform. So now we can write here that the x dot s separation speed, okay, this will be equals to a omega cos omega ts. Okay, a omega cos omega ts. Okay, so this value can be written as, and this x dot, this cos omega ts from the previous relation we can write, so 1 minus sine square omega ts from the trigonometric relation, and sine omega ts from the previous relation we can write, so a omega 1 minus g by a omega square and this whole square. Okay, so now substituting the values, so x dot s will be equals to amplitude a, which is 5 centimeter, that is 0.05 meter, omega which is equals to 20 radian per second, and under root of 1 minus g, which is 9.8 meter per second square, amplitude is 0.05 and omega is 20, so this whole square and this complete square. So from here x dot s will be equals to nearly 0.871 meter per second. Okay, so now applying the conservation of energy, so we can write that 1 by 2 m x dot s square, this is equals to mg h minus x s. Okay, so h is the height, which is the position from the maximum height, and xs is the separation distance. Okay, so hence from here h will be equals to xs plus xs dot square divided by 2g. So xs from the previous relation, it is equals to 0.025 meter plus x dot, which is 0.871 meter per second, this whole square divided by 2 multiplied by g is 9.81. So from here after solving, the height h will be equals to 0.013 meter, which can be nearly taken as 1.3 centimeter. So this will be the answer for the part B of the problem. Okay, thank you.